Hey everyone. Okay, we're back with our latest edition of Quadratics in Quarantine. Today what we're going to be looking at is a third quadratic formula, and that is in factored form. So I've given you standard form, that's the ax squared plus bx plus c one. We've just spent a little bit of time with vertex form, the y equals a bracket x minus h squared plus k. And now we're going to look at factored form. Now, actually in our next unit, we're going to be getting into factoring. You don't have to understand what that is here, but this is the result of it. So this is a parabola in factored form. And, well, just to basically go over what some of this means, A is going to still be your stretch or your compression. And if it's a minus A, like before, that would open down, where a plus A opens up. And the R and the S, these refer to the zeros. Never know if there's an ES there or an S, to the zeros. And these are where the parabola crosses the x-axis. So wherever it crosses the x-axis, those are known as the zeros. So let's try one of these. So if I give you the equation of a parabola in the form of y equals x minus 1, x plus 3. So first of all, you're going to notice that there's no a here and there's no negative sign. So this is going to open upwards, and it's just going to be your regular parabola, your over 1, up 1, over 2, up 4, over 3, up 9 parabola. It's not stretched or compressed. And this parabola is going to cross the x-axis at 1, negative 3. So I'll show you how we get that. Now, some of you can probably just graph this right away. I'll show you the whole process to see how we get to the graphing stage. So picking some random x values. If we were to sub in negative 3 into this, we would have negative 3 minus 1 times negative 3 plus 3. So I've just subbed in negative 3 in for this x and for this x. And we get negative 3 minus 1 is negative 4. Negative 3 plus 3 is 0. Negative 4 times 0 is 0. And if we do the same for negative 2, I believe we get negative 3. And I won't bore you with all that. Oops, I think I made a mistake here. Nope. So here are our values. And if we were to graph that, we have negative 3 and 0. We have negative 2 and negative 3. We have negative 1 and negative 4. 0, negative 3. 1, 0. 2, 5, 3, 12, not to scale, and we end up with a parabola that looks like this. So you can see this is a parabola that has been shifted to the left 1 and shifted down 4, and so here is our vertex at negative 1, negative 4. There's our vertex right there. So that is what this looks like graphed. Now, in this case, I can see where our vertex is, but what if we actually wanted to solve for it. So when I'm doing this type of question, I don't necessarily do this. I'm able to look at my R and my S, and I know it's going to cross here at 1. It's the opposite. And here's going to cross at -3. I know I'm opening upwards, so I know I'm going to have a parabola that looks like this, which is what we have. What I don't know from this is where my vertex is. And so rather than doing all this and having a whole bunch of points, I'm going to show you how you can just solve for where that vertex is. So the first thing in solving for where that vertex is the axis of symmetry. We want to find that. So going back, so I don't have to turn the page over again, we had a point at 1. We had a point, I believe, at -3. And we know that our axis of symmetry is going to fall halfway between those 2 points. So if we take our R value and add it to our S value and divide it by 2, that's going to give you our axis of symmetry. So in that last case there, we would have got -1 here. So -3 plus 1 divided by 2 equals -2 divided by 2, which equals -1. So that lets us know our axis of symmetry goes through -1. So for our vertex here, we know half of its location. We know it's at 0, 1. We just don't know the y value. And I'm going to show you how to get that as well. All right, so let's do another example here. Y equals x plus 4, x minus 2. Now it says to sketch the we're going to sketch the relation. Well, first of all though, let's find the x-intercepts. And sort of a good habit here is to do this. Just so we have our information. What's our A value? Our A value is just 1. It's just a normal parabola. No stretch, no compression. Our R value, right here, is going to be -4. And once again, it's like the vertex form that we did. It's the opposite here. If I put in a -4, x minus, if I put in a -4 for the R, that becomes a plus. So +4 means that a -4 had been subbed in. And likewise here, our S value is going to be, not S, our S value is going to be 2. X minus, if I put in a +2, it's going to appear as an x minus 2, hence the x minus 2. Make a long story short, these are going to be the opposite signs. So we know that our parabola is going to cross the x-axis at -4, and it's also going to cross at 2. We also want our axis of symmetry, and that's going to be halfway between these two. Using our formula, R plus S divided by 2, so we're just finding the average of those two. So equals -4 plus 2 divided by 2, which equals -2 over 2, which equals -1. All right, and the last thing we're going to do is we're going to find our vertex. Now, if I was to graph this, I know that I have an R value here of -4. We know that we are crossing the y-axis at -4. We have an S value of 2. That tells us we're crossing the x-axis also at 2. And we have a parabola with a value of 1, meaning it's just our basic parabola that's been shifted. And so we're going to have something like this. Now, if you're going to do this on graph paper, you wouldn't do this on graph paper yet because you don't know exactly where some of these other points are. In this case, though, I do know my axis of symmetry is right here. So we have -1. We just need to find that other value. And so we can do that just by subbing in this point back into our equation. So for the vertex, we have y is equal to x plus 4x minus 2. This is a formula we're working on. And let's sub this -1 in. So y equals -1 plus 4 minus 1 minus 2. So I just subbed in this x value for our x's. -1 plus 4 is 3. -1 minus 2 is -3. And 3 times -3 is -9. So we know that this point is at -9. This is actually when I would graph it. I just started doing the graph here so you can kind of see what we're getting at. But I would figure out my x-intercepts first. I would figure out my axis of symmetry. That gives us our x value. Excuse me. And then I can solve and get the other half of our vertex. So I'm going to whip through a couple more examples here. Just different ways that you might see this equation. But it's pretty much all the same thing. So y equals 2x. X minus 4. So this is in vertex form as well. What I would do here is I would add my brackets back in. All right. In this case, brackets have been left out. That's fine, but it would look like this. So we here have an a value of 2. We have an s value of 4. We know it's going to cross the x-axis at 4. We know we're stretching by 2. We know that we are opening upwards. And we're also going to cross the x-axis at, because this is x minus nothing, it's just an x, but that tells us that we're going to be crossing the y-axis at 0 as well. So we have our x-intercept. So here, our a is equal to 2. Our r is equal to 0, and our s is equal to 4. The second thing I want to do is find our axis of symmetry. So I'm going to add our r and our s together and divide by 2 to find the average. So we have 0 plus 4 divided by 2, which is 4 divided by 2, which is 2. So that's our x equals 2. And the third thing we're going to do is we're going to find our vertex. So I'm going to sub that back into our equation. We have y is equal to 2. Subbing 2 in for the x, we have 2. And then 2 minus 4. So 2 times 2 is 4, times -2, which is -8. So we have our vertex here is at 2, -8. And on graph paper, if you wanted to graph this baby, we have at 2, -8, so 2, -8 is our vertex. We have our zeros at here, we're crossing the x-axis at 0. We're also crossing the x-axis at 4. And you don't have to find the other points. Just with the 3 points you have, the vertex and the 2 zeros where it's crossing the x-axis, you can connect those. And this should make sense to us. A normal parabola is over 1, up 1, over 2, up 4. Well, this one here is actually over 2, up 8, and that's because we've stretched it by double. If you really want this other point, instead of over 1 up 2, it would be over 1 up. Sorry, over 1 up 1, be over 1 up 2. And you could get those other points, but no need. Just graph it with the 3 that you have. All right. Let's do another look here. Y equals x plus 3 squared. All right, this is looking a little bit like vertex form, but if we were to expand this out, this means the base squared. So we would have the base times the base. Our A value is 1, no stretch or compression. Our R value is crossing the y-axis at -3. And here, our S value, we are crossing the x-axis at -3. Wait a second, what is going on here? We have an R value and an S value that are the same. Well, what we have graphically is this. We have an equation where we are crossing the y-axis at -3, that's our R, and we're also crossing our x-axis at -3, so that's our S as well. So that tells us that we have a parabola like this. Because these are the same point, we are only crossing the y-axis at one place. So instead of 2 places like the previous 2, we are only at 1 place here. If you look at this in vertex form, this tells us that our H value, we would be shifting 3 spaces, our vertex 3 spaces to the left. And we don't have a K value. So you can see how vertex form and factored form do lead to the same. So our vertex here is at -3, 0. No need to find the axis of symmetry. We know that already from graphing it. And we no need to sub back in and get the y value because we can see it right there. So that's a nice easy one. When you recognize it in this form, it makes life really, really easy. All right, one more, and then we're going to be done. This is example number 4. All right, so once again, our factored form. And if I told you that our x-intercepts are -3 and 5, and we have a y-intercept of -75, could you graph this? Basically, what that's telling us is that we have something that looks like this. We know we're going to be crossing at -3. We know we're going to be crossing the y-axis at 5. We know we're going to have a parabola that looks something like this. Actually, I think we can agree the vertex would be over here somewhere. Right now, this is just for illustrative purposes. And I know that we cross this parabola is going to cross our y-axis at -75. That's not the vertex. The vertex is down here. But we know we're crossing at -75. So what is the equation for this? How can we take this information and put it into that? So let's do that. Y equals A, x minus R, x minus, minus S. All right, let's put in what we know. We know R is -3. So for R, I will put in -3. And I know S is 5. So I'll put in a 5 for that. And so we get x plus 3, x minus 5. Now I know a lot of you looked at that minus 3 and know it would appear as a plus 3, looked at that 5 and it would be a minus 5. If you want to skip this step, go nuts. I would not do that. I just, once again, am trying to show you that what you see here, these signs are the opposite of what we actually have. All right, so that's that. The only thing we have to know is, do we have a stretch or compression? So let's find our axis of symmetry. So that is r plus s divided by 2. We have 3 plus negative 5. And actually, my bad here. I did that backwards. Sorry, we have a negative 3 and a plus 5. So negative 3 plus 5 is positive 2, and we have a positive 1. There we go. There's our axis of symmetry at 1. Too early in the morning. And continue on then. Let's solve this. So we know we're crossing at minus 75, so I'm going to add that into our formula as well. So we have, for y, we have a minus 75. And I'm going to sub in everything we have here. So 1 plus 3. And our other x value, or sorry, our x value is 1 minus 5. We get something like that. Four times negative 4 is negative 16, which we would write as negative 16a. Bring that to the other side. Let me find my calculator here. So negative 75 divided by negative 16. We get an a value of 4.6875. So our equation then is y equals 4.6875 x plus 3, x minus 5. There is the equation for this. We are crossing the x-axis at negative 3. Boom. At positive 5. There it is. We know our axis of symmetry is negative 1. And we know we have a stretch value of 4.6875. So there you go. In this case, you don't have to graph this one. Once again, my graph was just to help you visualize what is in the equations and numbers. So that is that. I hope you have some success with it. If you are having any sort of difficulty on any of the questions or need clarification, as some of you have, reach out to me and I'll write up solutions or write up whatever I think might help you out and get that back to you. Have a great day, everyone.